everyone, my name is Vineet. Today I'll be giving an overview on convolutional neural networks and transfer learning, two very interesting topics in deep learning. Almost all the applications that you can see around us are powered by AI, be it facial recognition, biometrics, or even classification of an object, or the drones that are flying around you for security surveillance. All are backed up by AI. Machine learning and deep learning are two popular frameworks that you can use to build such applications in few lines of code. Yes, you heard that right. All thanks to the high-level, easy-to-use API, sklearn and Keras. Just to provide a background overview on machine learning, deep learning, and CNN, and to connect the dots, let me just tell you a short story. So, we all know that in traditional programming, what used to happen was we used to have certain sets of input, and we used to write the programming logic. Like that's what we learned DSA for. And based on that, what we used to do is we used to provide the programming logic to the machine. Now, what does the machine do? Simply is it takes the input from the user, puts that input in the logic built by us, and voila, you get the output. And that would be correct or wrong based on how efficient your particular logic is. Now, that's the reason we used to call machines as dumb machines, because they don't have any intelligence of their own, something that humans are, famous for. But coming on to certain complex tasks, like for example, facial recognition, or let's suppose you have to classify an object into 1,000 different classes. Now, for tasks like these, it's not possible to form if and else conditions, right? It's not practically possible. For example, let's suppose I have to classify an object into whether it's a human, it's an alien, it's a cat, or it's a whale, or it's a dog. So I need to have certain sets of features based on which I'll be able to, segregate these a particular object into various classes. Now, just practically think of an example, like how can we do that? For example, a particular class, let's suppose you are defining 50 features based on height, color, gender, and all of particular features, which is very difficult to come upon such features. Let's suppose you are able to define 50 features for a particular object. Then if you have to do a 1,000 class classification, then on an average 50 features per class and 1,000 classes will lead to 50,000 features for a single image. That means in the database you'll be having 50,000 columns, and God knows like what those columns can be and those names can be. And for every particular instance, you have to define all those 50,000 those parameters, or you can say the features. This is like practically impossible to compute, because even as humans, we don't know, like for example, if you have a dog and a cat, what particular set of features exist, solely on the basis of which we can say this particular features means it's a cat, or this particular feature means it's a dog. So put it up simply, machine learning, what it does is, it needs that particular set of input features, it takes them as input, okay, and we apply certain machine learning algorithms, and based on that, it will give you the corresponding output. The most important part here to note is that defining such features is very difficult, because as humans, we are like, whenever we see an object, we can instantaneously say like, oh, that's a dog. But we are not computing anything like if and else condition. So it's very difficult to intuitively understand like how does that thing happen. And this feature extraction part, it's a very tough thing to do. Practically, if you have to do a 1,000 class classification using manual feature extraction, it's going to be a very hectic task, and it's something that no one does. Now, how do I overcome this? Almost all the data scientists have this question. I don't want to, indulge into feature engineering. Can I have something that can do the feature engineering on its own? And voila, here we have deep learning. For example, if you have to do the same task using deep learning, you just need to have one input image and one output. That's it. You don't need to have anything else. Images, input images, and the corresponding outputs. That's it. The model, especially called convolutional neural network, takes an input image as an input, and then what it does it performs certain set of operations on that thing. Convolutional layers followed by max pooling, batch normalization, dropout. In sequence, we can actually build a huge network, and based on that network, it can easily classify what class the object belongs to. Alright, now, the beauty about convolutional neural networks is it takes the relationship between adjacent pixels, or you can say neighboring pixels, into account. So hence you can provide the entire two-dimensional image if you're talking about grayscale, or even you can increase the number of channels to 3 or 4 to take into account RGB images. Directly you can feed the image to the model and it will give you the corresponding label. Here the feature extraction part is done on its own. How does that happen? The initial few layers in the model, they will be actually learning about the edges and few minor details. And as you keep progressing, the layers towards the end, like you can see the end layer is actually a dense layer having number of units equal to the number of output classes you want. Here we want a 1000 class classification, so we will be using 1000 units in the dense layer in the final thing. So towards the final layers, actually the edges in the initial layers are combined to form, certain parts, certain shapes, and those are combined to form a particular face or particular dog structure and something like that. So the you can say the latermost layers, they are able to actually visualize the entire thing. So this is how convolutional neural network works. And because of this simple fact, we can simply conclude that you can say that using CNN and deep learning actually is very easy, because you just need an input image. You don't need to take into consideration the feature extraction part. If you have 1000 different classes, and if you have, let's suppose, 100 or 200 images per class, so you'll end up having a huge data set. You just need to provide an input image and an output label. That's it. You don't need to do any kind of feature extraction, contrary to machine learning, where you needed to explain those features, because machine learning models can't directly work on the pixels. Because if you directly give an input of an image to a machine learning model, it will just take those pixel values into account, and those pixel values are just numbers, and they won't be we won't be able to fetch important information from them. That's the reason we go to CNN. So in CNN, we'll be able to train a model, and model training takes a lot of time. Deep learning is data hungry. That's the biggest drawback of deep learning. In order to train a deep learning model, you'll need lots of data. So certain tasks like image segmentation, image localization, object detection, making the bounding boxes, these kind of complex phenomena can be easily done using CNN. And also, we just need to do the annotations. That's the extra part. Like, we need to specify some set of coordinates in order that the boxes can be drawn and stuff like that. So now the biggest thing is, let's come on to the interesting part. For training CNN models, we just need to provide it lots of experience. And how do we gain experience? By practicing. That's a very well code set, right? What happens is, we have to feed, since we are just feeding the images, we have to feed lots and lots of images to the model. The model is data hungry. The more the number of images you have, then only it will be able to gather the information from all of those images, and then only it will start making sense to the model, right? So you need to make the model practice a lot. That is, you have to send lots and lots of data. For example, if you're going for a 10 class classification object, then what you need to do is, at least for each class, you need to have at least 500 images. Along with different orientations of the image, we also need to ensure that we have different varieties of images. The reason we are saying that is, let's take a simple example like cat versus dog classification. It's a very famous thing in deep learning. Here we can simply observe, like, if you just take the picture of one breed of a dog, that's it, and then you just train your model on that, then it will basically become that you are predicting whether it's a particular breed of a dog or not. But our objective is dogs in general, and we know like there are thousands of categories of dog. So we need to ensure that there is a balanced distribution of the data set belonging to various. That is, in simple terms, you can say that your data should be in such a way, it should be sampled in such a way so that it is able to, present the distribution of all of the classes in an equal manner. That's how you can ensure that the model you'll be building, it will be able to recognize almost all kinds of breeds that it has come across. Now, this thing. Now, coming towards the end part of the video, I know that making a CNN model and having thousands and 10,000s of images and then training them, it's a pretty easy thing to code out, but in reality it takes a lot of time for the training part, especially when you have deeper networks. It will take a lot of time, and especially if you're going for 10 class classification or 50 classes, 100 classes, more number of classes, and you need more data. Now there is a problem. Now here's the problem. Like, for example, if you don't have that much of time, let's say you have an assignment to submit and it's due in 10 hours, but you know that you're training your model might take 20 hours or maybe a day, provided that you don't have enough GPU. In that case, what we can do is, there's a beautiful thing in deep learning called transfer learning. As the name suggests, transfer the learning. For example, let's take a simple example. For example, there are two people. One who, you can say, he doesn't know a particular language, right? And there is one more person who knows Java. Now, if I have to teach them C++, For the first person, I have to teach him from scratch. So that's going to take a lot of time, right? Because I have to teach him from scratch. But for second person, since he knows Java, and we know like for any two programming languages, the structure and everything remains the same. Only the syntax, the way we write changes. The for loops and while loops, they all remain the same. In that case, training the second person who knows Java already and making him learn C++ is just a simple mapping, because the knowledge in both the domains is almost the same. And this is what is known as transfer learning. That is the transferring the knowledge gained in one task to another task. And where can we use this? Practically, if I have to do a 50 class object classification or a 10 class object classification or any kind of these tasks or image segmentation or drawing a bounding box, I will try to use a model which was already trained before on a huge data set, on millions of images. Like AlexNet is there. There are various models, there are pre-trained models which have been trained by big corporations like Google, Microsoft, etc. They have been trained for months on millions of images. Now what I can do is, I can actually utilize that model and I can make sure that I use that particular model and its weight file. Ultimately, model defining is very easy. You just have to add a few model.add statements and voila, it's good to go. But the main thing is, the entire thing in deep learning is we are going through a forward prop, calculating the loss, backward prop, updating the weights. Only thing that we are doing is updating the weights. If we get the weights straight off, I don't think like we need to even do the training. That's what we do, right? Once the training is done, we save the weights and that's it. Next time we use the same weight, load the model, and we can do the inferencing. That's what we are going to do in transfer learning. We utilize a model which is already being trained. What we do is we pick up its architecture and weights. What we do is we unfreeze the last few layers depending upon the need. So that I'll be talking about in just a few minutes. We'll be unfreezing some layers, and after that we'll be putting in the data that we have through this model. Now, we are not making the model learn from scratch. That's the reason we are just unfreezing a few layers. That is a few later part of the layers where the overall representation is being learned. As I described in the earlier part of the video, the initial few layers actually learns few basic things like edges, eyes, or some particular shapes. And you can say the later part of the model, they actually try to combine all of those things and actually tries to see in which particular class your object lies. Let's say that the first model is trained on detecting cars. Now, for example, your project is based on detecting trucks. Since these two are almost related, what you can do is you can use a pre-trained model which is already trained on cars and utilize that model to actually work for your particular data set. Now, how does that happen? Like I said, you just need to, you just need to freeze the initial few layers. You have to keep the last few layers. You just have to modify them. For example, in the last layer, always we have a dense layer containing the number of neurons equal to the, you can see the output classes. For example, if it's 2, and for example, if you need to change it here, for example, you are doing truck, lorry, and different kinds of things, and you're trying to do a 5-class classification, then you need to add a few layers at the end, and you need to ensure that towards the last you add a dense layer with 5 units. Okay, now adding a few layers, freezing the entire network till then, you can notice that the number of parameters to train is effectively the ones towards the last, which would be very less. And obviously, if you have to train a model from scratch, obviously the number of parameters will be more because you have to go from here to here, and ultimately it will take a lot of time. But if you go for transfer learning, you just need to train the last 2 or 3 layers depending on the data you have, and voila, you're good to go. Now, the most important question is, when do we use transfer learning? First of all, transfer learning can be used if you are trying to solve a problem which is already being done by someone else, that there is a model existing which is known to perform very well on a particular problem. You can utilize that model to work on your thing. Second thing is, if you have less amount of data, that's the biggest thing when we use transfer learning. Let's suppose you have less amount of data and you are not able to arrange for more data. In that case, we always know, if you're going for, let's suppose, 5-class classification and you just have 100 images of each class, that is in total 500 images. So it's an obvious fact that you can't train a CNN from scratch so that it can work well on those 500 images. 500 images for 5 classes is way too much. And obviously you can't expect your CNN model to work better, because if you use more number of layers in your CNN model, your model will ultimately overfit, which is not going to perform well on the new data. That's when we make use of transfer learning. And since I have less amount of data, I'll just unfreeze the last one or two layers, and I'll be adding one or two layers extra, and that's it, I'll train it. So that's how transfer learning works in brief. And where does transfer learning fail? So there are 2 points where transfer learning can fail. The first point is, let's suppose you are, the domain on which the model is trained is, let's suppose, x1, and the domain that you are trying to solve is x2, and there is no intersection between x1 and x2. Those are completely two different domains. Then you can't expect like a person who knows Java and the person who can speak Japanese. There's no relationship between these two. So ultimately, you can't club them both. Okay, transfer learning, that knowledge of transfer happens when the domains are related. Next thing, and the most interesting thing that I found out after a bit of research that I've done on this topic is, let's suppose you have more amount of data. For example, you have 5,000 images or 50,000 images. Then going for transfer learning again won't help that much. Reason being is because like if you have less amount of data, then the last few layers won't be trained that much. But by just giving a less amount of data, at least that representation will be learned. If you are unfreezing just a few layers in the pre-trained network and you are providing lots and lots of data that you have, in that case, what will happen is scientists have observed that actually the model performance goes down because a lot of noise will be added because of the lot of data set that you are providing. So in simplistic term, what I can suggest you is, if you have huge amount of data, then you can always go for building a model from scratch and training it. If you have less amount of data, then obviously building a model from scratch won't help because the accuracy attained won't be that high. And also data augmentation does help, but if you don't have huge diversity in the data, then data augmentation techniques also fail up. Hence, you can say transfer learning will be most beneficial when that you have a pre-trained model in that particular subdomain, and also that the data that you have currently is less. And also transfer learning don't take that much of time in training. They will be trained very fast because you just need to, unfreeze a few layers. And if you have more amount of data, like I said, if you have huge amount of data and you just unfreeze the last 2 or 3 layers, then a lot of noise will be added, and you'll observe that after a few epochs, the model will start performing even worse. To overcome that, what you can do is either you can build a model from scratch, like I said, or the best approach would be that I generally do in competitions is I will unfreeze 50% of the model. Yeah, so you can actually unfreeze more number of layers so that the number of parameters will increase, and yeah, you can actually make all of them learn. So that will work fine. So that's it about transfer learning, CNN, and all of those things. I hope you like this video. The main motive of this video is so that a lot of competitions do come up in image domain, and whenever it is something related to image and video, deep learning is the first thing that strikes our mind, because when the number of output classes are more and when these kind of complex issues take place, deep learning actually works the best. And I guess by now the reason should be clear to you. Just a hint, feature extraction is done automatically in deep learning. That's it. That's me, Vineet, signing off. See you in the next video. Thank you so much.